Okay, here's our equation that we're going to use, and we're going to solve this problem. And I'm going to solve it both ways with the equilibrium approach, like an ice table and then a Ka value, and then use the Henderson-Hasselbalch equation to show you that they are both a viable approach to solving the problem. All right, so here is our problem. And if I'm going to do this problem with an equilibrium equation, I got to set up an ice table. Which one do I use for my ice table? Well, you're going to use the one that's not going to dissociate completely. So this one, the weak acid, not its conjugate base in this case, because this will completely dissociate. Boom, bada boom, it's going to go. All right, so I'm going to set this up plus water. This is going to donate a proton to water. Going to be left with that. There's my equilibrium equation. I'm going to plug my molarities in like that. That's going to be just the molarity of the benzoate ion. Okay, this is going to go down by some value x. These are going to go up by some value x. And I'm going to go up there. Now, I'm going to plug that into the general Ka value equation. That being my Ka equation. And instead of this one, I'm going to use this equation. All right. This is going to go here. That's going to go there, and that x is there. And I'm neglecting the x's here. So this is just going to be my 0.05 and 0.15. When I've substituted, it's going to look something like, now I'm getting a little fancy. Before I substituted, I rearranged this for hydronium. You could do this or substitute at the front. I think in some ways it's easier to rearrange the equation prior to substituting. So that's why I did this, all right? Then I substitute in. Here it is. Now, you could do this on a calculator and then take the pH if you wanted. Or what you could do, and which I'm going to do here, is I'm going to take the negative log of both sides. All right? And clear. And I'm going to plug that in to my calculator, 6.5. And I get that, 4.66. All right? That's my pH. Boom. Now, let's do the same problem using the Hasselbalch approach. The double H approach. Incredible. Henderson, I don't know what I said. Oh, so here we go. Here's our equation. Remember that pKa is the negative log of the Ka value. Here's my Ka value. So I'm going to plug that into this equation and rewrite it again. All right. And then I'm going to plug all my values in. So negative log is this plus this. You could reduce this down to 3 if you wanted to, if you're like super cool, like a log expert. And then you're going to do it. Negative log 6.5 second e to the negative fifth parentheses plus log of, and we'll go with the originals, 0.15 divided by, almost made a huge calculator mistake. What do we get? We get 4.644, which I didn't write. How dareth I? 4.66. If you remember, that's the same way from before. Yes. The Henderson-Hasselbalch approach has been used, has been tested, and has been stamped with our AP Chem stamp of approval.